Hello students, welcome to my YouTube channel GATE Metallurgy MT. In this video, we are going to see the memory based questions of GATE Metallurgy organized by IIT Roorkee on 1st February 2025. These questions are collected from metallurgy students of various colleges who took this exam on 1st February. Later in the video, we will discuss what was the difficulty of the question paper and what could be the cutoff for this year. So now let's get started in the video. The number of octahedral void in pure copper FCC crystal structure. So first of all, we will write the crystal structure, octahedral and tetrahedral sites for FCC and BCC. Then we will take the correct answer. So size of interstitial voids and number of octahedral voids in FCC and BCC crystal. So now we have drawn the table, and from the table we can see that these four values are the size of the octahedral and tetrahedral voids for FCC and BCC crystal given with respect to radius. And just below all this we can see the numbers, that is 4, 8, 6 and 12. These are the octahedral voids and tetrahedral voids respectively for FCC and BCC. So for our case, they have asked about octahedral voids for FCC. So FCC and octahedral voids, so 4 is the correct answer. Now we will move to the next question. This question was from flow through pipe topic, and that was a MSQ type of question. According to question, the expression for maximum velocity of a fluid flowing through a pipe of length L, pressure drop delta P, dynamic viscosity mu and radius R is proportional to. So we have to find the proportionality constant for maximum velocity. So for fluid flowing through pipe, we know the relation between maximum velocity and the following terms. Suppose that we have this diagram here. This is a pipe. In this, the velocity profile looks like this, in which maximum velocity at the center, and during the derivation we will see that this is distance r taken from the center to the periphery of the pipe. For the maximum velocity we can write the relation Vmax equals to 1 by 4 mu minus delta P by delta x into r square minus small r square. Capital R is the radius of the pipe, mu is the dynamic viscosity, delta P is the negative delta P is the pressure drop, delta x is the length of the pipe, and small r is the distance from the center. Clearly from the diagram we can see that the maximum velocity is proportional to 1 by mu. This is also proportional to r square. This is also proportional to delta P, that is pressure drop, and this is also proportional to 1 by L. So for this case all the four options were correct. So now we will move to the next question. This question is from thermodynamics topic and from phase transformation. So question is like this. In the figure we can see that there is a pressure on the y-axis, there is a temperature axis on the x-axis, and now there is a graph for alpha to beta to liquid, and this is the transformation diagram. So according to the given question, the phase transformation, the enthalpy change from alpha to beta is positive. So from changing here to here, there is a positive enthalpy. Similarly, enthalpy for phase transformation from beta to liquid, this one is also positive. What will be the relation for volume of alpha to beta and volume for beta to liquid? So we know that according to the Clapeyron equation, dP by dt equals to delta H by T delta V. In this relation, we can see that graph is always increasing at each of the point. So when we will draw a tangent to this graph, it will be always in the positive direction. So from this we can say that dP by dt is always positive. So according to the statement, this term is always positive. Also in the question it is given that delta H is also positive for both the transformation from alpha to beta and from beta to liquid at a particular temperature, that is also a positive quantity. So all the terms in the Clapeyron equation is positive. So we can easily say that for the phase transformation, the delta V term, that is change in volume term, is also positive. So what do we mean by saying that? That means when there is a phase transformation from V alpha to beta, we will see that volume of the beta phase is larger than volume of the alpha phase. So we will write V alpha is less than V beta because V beta is more. Similarly, we can write V beta is less than V liquid. That is, volume of the liquid phase is more than volume of the beta phase. So for this case, this is the correct combination of answers. Now moving to the next question. According to the question, the relation of exact differential for thermodynamic system m dx plus n dy equals to 0. So this is pretty simple equation for exact differential. According to the condition of exact differential, del by del y equals to del by del x, and we will change the variable for this m. From y to x, it will be x to y. So it will be n here, it will be m. So for this case, this is the correct answer. Now moving to the next question. According to this question, the correct sequence for non-pressurized sprue runner gate ratio in terms of area, that is missing here. So for non-pressurized system, we have to understand that suppose that this is the sprue, this is the runner, and this is gate. So this is gate here, this is sprue, and this is runner. For non-pressurized system, so there is no development of pressure. When there will be no development of pressure, suppose that we have the area ratio as 1, 2 and 3. That means area here at sprue is 3 times, area here at runner is 2 times, and area here at gate is 1 times. That means area at gate is lower and area at sprue is larger. So there is a development of pressure from sprue to the gate. So this is called pressurized system. And what will be non-pressurized means exactly the sequence will reverse. So the area of this gate should be larger than the area of the runner and thus area of the sprue. So the correct sequence from here to here will be 1, 2 and 3. From moving from top to down, the area should increase. So for this question, option B is correct one. The only sequence where area is increasing. In rest of the case, area is decreasing. So now we will move to the next question. Next question is, we have to find the flux through the conduction between the walls, and this material is pure copper with thermal conductivity K, and the two temperature at the two surface are 500 and 1000 degrees Celsius, and the width of the wall is 0.4 meter. So the flux we can write as Q equals to delta T by RTH, that is resistive thermal equivalent. We can write Q equals to delta T, that is change in temperature. So it is 1000 degree minus 500 degree divided by RTH, that is L by Ka. We have to find the flux per unit area. So we will move this area to the other side. So it will come here and we will have unit as watt per meter square. Now we will substitute the value like 1000 minus 500 divided by length, that is 0.4 meter, divided by thermal conductivity, that is 400. Everything is in same unit, so we will directly calculate from here and we will get 5 into 10 to the power 5 watt per meter square. As asked in the question, that is this integer value. So 5 is the correct answer for this question. Moving to the next question. According to this question, the effect of increasing nickel content on the hardenability of low alloy steel and MS temperature is. So in question they are asking what is the effect of increasing nickel on hardenability and MS temperature. The term hardenability is defined as the ease of formation of martensite. That is how easily a martensite can be formed. According to the effect of nickel on the low alloy steel, that is, this shifts the TTT curve to the right. That means, so this is a TTT curve, and what happens that there is a shift in the graph from left to right. That means now the martensite can be formed with even a slower cooling rate. Now this one MS Instead, where earlier we have to go from miss the nose and then we can form martensite here. Now with a slower cooling rate, it can form martensite here. So the effect is slow cooling rate. A martensite can be achieved. So the hardenability is increasing. Why this happens? Because nickel is a austenite stabilizer due to FCC crystal structure. Thus the carbon solubility increases in. So the hardenability increases. Now for MS temperature, as nickel is a austenite stabilizer, the regions of gamma ferrite expands. Suppose that this one we have iron carbon diagram here. So this is the gamma FCC structure. And now what will happen that this region will expand. So due to increasing of this region, gamma ferrite, the area of this alpha ferrite reduces. Alpha ferrite reduces. And due to this reduction, the martensite formation is difficult. Is difficult at high temperature. So now the martensite has to be formed at lower temperature. So MS temperature decreases here. So for this question, hardenability increases and MS temperature decreases. So from the four options, we can see that option C is correct, where hardenability increases and MS temperature decreases. Now moving to the next question. According to this question, for the first order kinetics phase transformation, so this is first order kinetics, the time required to complete 20% transformation was 2250 seconds. Now we have to calculate time required to complete 50% transformation. Now we know that for phase transformation kinetics, we have Abrahami relation, where fraction phase transformation f equals to 1 minus exponential minus k t to the power n. In this case, we will say f is fraction transformed, k is rate constant, t is the time, n is the Abrahami kinetics exponent. And we know that for first order kinetics, for n equals to 1, this is the special case of Abrahami kinetics. We have equation f equals to 1 minus exponential minus kt. In this case, n equals to 1. And this is the equation for first order phase transformation kinetics. For more clarity, we will see that this is interface controlled, or rate of nucleation is constant without acceleration, whereas Abrahamic kinetics is used for nucleation and growth. In this case, the rate of nucleation and growth changes over time. So now we will solve the question. For case 1, we see that there is 0.2 fraction transformed 1 minus exponential minus k into 2250 as the time. This is for 20% transformation. From here we will write 0.8 equals to exponential minus k into 2250. We will take natural log and then we can write k equals to negative of ln 0.8 divided by minus 2250. This value comes to be 8.924 into 10 to the power minus 5 per second. Now for the second case, we will see that there is 50% transformation. We have to find the time. Now we know the value of k, so we will put here the value of k and solve. We will get, now taking the natural log and solving for t, that is t equals to ln 0.5 by minus k, that is ln 0.5 by minus 8.924 into 10 to the power minus 5. After solving this, we will get 0.6931 divided by 8.924 into 10 to the power minus 5. We will get, so we made a calculation mistake here. So it will be 9.917 So we will replace this with 9.917 and we will get 0.693 divided by k, that is for 50% transformation for first order kinetics, and after solving we will get 0.06989 into 10th power 5. So we can say that this is 6989 second is the time required for transformation up to 50%. There may be the variation in the answers due to time taken here for 20% transformation, because some students says that this is 2231 and some students says that it is 2500 also. So that will vary according to the answer, but overall the process remains the same. So now we will move to the next question. According to this question, which of the following option is or are correct? So this is MSQ type of question. According to the first statement, edge and screw dislocation both can climb. So we know that edge dislocation can only climb, it cannot cross slip, whereas screw dislocation can only cross slip but cannot climb. So first option is wrong because it's saying both can climb. Similarly, edge and screw dislocation can both cross slip. So again this is also wrong because both cannot cross slip. Third option is in screw dislocation. In the third case, the screw dislocation, the Berger vector is parallel to dislocation line. So this is correct. In screw dislocation we know that Berger vector is parallel to dislocation line, where for edge dislocation Berger vector is perpendicular to dislocation line. So this is true. Fourth option, the only screw dislocation can cross slip. So this is true. Cross slip happens only in the screw dislocation. So there are two options are correct for this question. Now we will move to the next question. In this question, which of the following statement is true about the optical microscope that will have vast resolution? So we know the resolution formula for optical microscope, that is D equals to lambda upon 2 into numerical aperture, where lambda is the wavelength, numerical aperture. So best resolution will have for those combination where D value is minimum, because this is the resolving power of optical microscope, that is it is able to distinguish between two particles separated by some distance. So D should be minimum. So for this case we have to have lambda as minimum value and numerical aperture as maximum value. So for this case we can see that lambda is minimum in this two case and numerical aperture is maximum for these two. Numerical aperture is maximum for 1.2. So this is true. So for this case option B is true, where 400 wavelength is true and 1.2 numerical aperture is true. Now we will